timing and being solid, keeping the timing. Trombone is maybe it's a different thing.
So how did you come into playing instruments? Did you do that from early childhood, or?
Yeah, I guess it was, I grew up in Upplands Väsby, in a suburb of Stockholm, and it's very good. The kommunala, the municipal music school at those times in the 80s, that was really good. And I was just fortunate on meeting the right people. So it turned out for me, like my teacher that I got the first time, he was also a semi-professional jazz trumpeter.
So this was like in grundskolan, so to speak? In the
basic education? So I started with, the recorder in the 4th grade. And then I quickly moved into, I started on trumpet. Oh. But then I've been falling down, trumpet, tuba, trombone, tuba. And, for me it was really great. And, my grandfather was grandfather. He was also a musician. So I guess there's some.
So you heard a lot in your childhood as well?
Yeah, he passed away early, but my mom could play a little bit. So.
But this is, I grew up in Borås when I was a kid. I played a lot of football, but then I went to the municipal music school, and I played piano and I played the trumpet. So but the unfortunate thing with trumpet and trombone is the embouchure. You need to have your stamina.
Yeah.
So if you don't play, it's not only that I can't remember how to play it. It really sounds shit when you don't have your lips in order.
No, it's like an athlete.
It's an athlete. You have to practice and train.
And I had periods of time where I practiced, up to 4 or 5 hours a day.
Really?
And
for the trumpet or for the trombone?
Trombone and tuba, interchangeably. And I did my military service in music.
In the music, of course.
Group music, Arméns musikkår. So
did you do the marching around the castle?
Yeah.
What was the biggest musical event that you had during your time until now, in terms of playing in public, or the biggest highlight, so to speak, from a musical point of view?
I don't know. I mean, it was kind of fun. When I was in the army band, we played, Bärvalhallen and did these big shows. And, but then, I played festivals, and it's hard. I mean, it's more when you play jazz. It's more about. It doesn't matter, if it's a fancy venue, if it's
who
just
you play
who
with,
you play with, and the connection you get with the other players.
It's almost extra cool if you play at dive places, right? Or some kind of.
Yeah, but so I played a lot of private parties, and sometimes it just happens.
But let's rephrase the question: which moment is the biggest musical moment in terms of who you've been jamming with? Like if you semi-professional, then the pros join in sometimes, and you get starstruck. You meet some big legends.
One big. I was playing Västerås Konserthus one day. I think there was the inauguration, and after us, Povel Ramel played.
Oh.
And that was starstruck, We had our dressing room next to him, and we can hear him, rehearsing and warming up, and, we met in the hallway and exchanged a few words.
So you were like the pre-band, so to speak, to him?
Yeah, so I knew a couple of people from Västerås, and he had composed a piece of music, and I was playing in the band.
But then you actually said you played with the legend quite recently.
Well, exactly. So I met with Jan Allan,
famous trumpet player.
Yeah, exactly, famous trumpet player, and so we have a kind of a jam session group in Uppsala, and. And occasionally the man who organizes that has, a lot of connections, and, he talks to all these legends, because he's the chairman of Lars Gullin-sällskapet. So he's kind of preserving the legacy of some, jazz.
Lars Gullin, famous jazz.
Exactly. And, writing books and keeping track of what they've been doing.
So this Jan Allen just came around somehow? Or?
Yeah, so basically he doesn't get a lot of gigs, when you're 87.
87.
And, he think it's, of course he
loves to play.
These guys, they love to play, this has been their entire life. So, and, we came with the car and we took him to Uppsala and he sat down and played, and then we,
what's his most, I don't know him that well. Can you mention, some of his most famous moments, so to speak, from Jan Allen?
I mean, he was part of the whole Swedish jazz explosion in the 50s, Nalen and all of those settings.
Here in Stockholm.
But he's probably mostly known for the general public as being part of Hasse och Tage, all the shows.
So he was in the band behind Hasse and Tage?
Exactly, and it was interactive. So, so if you've seen Picasso's Äventyr, the movie with them, he has a part in there when he plays the trumpet.
And I think if you Google Jan Allen and you listen to, you will recognize some very classical Swedish jazz highlights. That is sort of even jazz with some traditional Swedish folk music that has been jazzified, so to speak. Jan Allen has some very famous pieces.
Lately he has a kind of a soft, mellow approach, and usually nowadays he plays trios or smaller bands. So he's not like a muscle, big band trumpeter type of guy. It's more a mellow, lyrical player.
Yeah, I always feel I get some kind of minority complex, when I meet these kind of people. Henrik, you're great at piano playing.
Not like this.
And the other Henrik here is awesome as well in playing different musical instruments. I'm only good at playing or singing bad karaoke. So I wish I'd had some more talent when it comes to music. And I actually like dansband music as well, which is not really a compliment according to some people.
We always had the joke. I guess Lars Albertsson as well, and the classical joke was Lars. Är det dansband på this is Spotify times? Is it Anders who's owning the playlist this Friday?
Yeah.
Friday music.
And then Lars is more hard rock guy, I guess.
Yeah.
If I remember it right. It's fun. Music is beautiful because it's sort of, we have connections to it in different ways.
And exactly. And for me, it was also the connection with music and mathematics has been really following me. So when I went after, I went to Uppsala to study, I did a lot of math, and then I actually wrote a paper on kind of music in math. So it was about, if you have a piano, basically, you have to go into physics and harmonic series, and so a piano is a compromise to minimize kind of frequencies and how they interact, because a natural harmonic series is integer based. So a piano, the errors are evenly distributed. So it's the 12th root of
the keys. You mean on the piano?
Yeah, the frequency relationship. Or the keys.
For the keys, yeah.
And so it's kind of evenly distributed. So a major third is 14/100ths of a semitone too high, and there are a couple of these things. So what the paper I did was about, well, let's say you have other number of keys instead of 12. Can you get a better system where you can be closer to pure in tune physical harmonics?
Yeah.
And you can prove that the next best system has 53 keys, I think.
Really? Oh. Yeah, so cool.
But maybe that's your angle, Anders. If you attack music from the math perspective and get hooked in that way, and you learn a musical instrument like mathematically, then you can, with your brain, get into the music brain.
Well, I think I have to resort to, there was actually the first album that was AI produced was with Amber, the actual software for that. And there was this kind of person that was always a bit frustrated with that she couldn't sing or she couldn't play an instrument, and I can recognize with that. But she really was interested in music. And when AI came about, and you can use software to actually produce like bands and different instruments, and then also help with the song, it actually was a big release. And it basically democratized a bit, I would say, music to people that are not that talented.
Yeah.
I like that.
But there's also, if you haven't heard, there's this classic book called Gödel, Escher, Bach. If you Douglas Hofstadter, a writer.
Yeah.
And it also talks about the relationship between, Gödel's incompleteness theory, MC Escher, these paintings with the staircases and these optical illusions. And Bach, Johann Sebastian Bach music. And, before AI, there was a lot of, analysis of, fugues and the type of music Bach made. And it's actually very sophisticated, the structure mathematically. And there are people trying to describe these type of music in terms of algebra, like groups and rings and this type
categorical theory in music.
And also trying to, recreate this type of. So I can really recommend that book. It's a really good.
That's interesting. So then this is cross-disciplinary, like.
Yeah. So he was trying to connect these, three geniuses together and see. It's a nice book.
That's awesome. Cool. Awesome. Well, let us welcome you here. And it's a true pleasure to have you here, Henrik Löf, who is an old friend and colleague of mine. And we worked together during Spotify years as well. And you have very interesting background, I think, from both being worked with Oracle, and you have a PhD that's interesting for many reasons. And I hope we get into that. And also now working at the Karolinska University Hospital as well, and continuing in a very interesting field. So, it's an honor to have you here, Henrik. And perhaps, how would you like to describe yourself? If we start a bit from the background and just, who is Henrik Löf? How would you describe it?
Yes, I really like to understand how things work. So I'm a little bit of a tinkerer. And, also, being music, I can enjoy being on the artistic side and really not understanding things, but just see what happens.
Right.
So I'm not super rigid in all times. But
isn't that like deep learning? You don't really understand how it works, but you still tinker with it?
Kind of. I guess we'll come into that.
And of course you're doing jazz in that case.
Yeah, so improvising and, doing things you really can't explain. A lot of times you can't, if you're in playing something and you can't really, stuff just happens unconsciously, and that's
driven by your unconscious mind in some way.
I'm being in the zone, where you really are one with the problem, so that's kind of been stuff I've been doing. So I have, a little bit of talent for math and abstract thinking, obviously led to the career. But
it sounds like, when I had my flipper days, when I play flipper games, you come into the zone and suddenly you just focus 100% on something and you don't even think consciously.
Exactly. You just do stuff.
Yes.
And, I guess gamers can get into that, feeling as well if you have
the flow.
Yeah.
Yeah. Cool. And if we start with your PhD, perhaps, can you start talking a bit about why did you start, pursuing a PhD?
Yeah, so I was very into math at Uppsala, so I did I picked together classes, randomly. I didn't go do a program or stuff like that, so I ended up doing a lot of math. But I also, when I came to Uppsala, I already knew how to program. So I've taught myself, and we had also in my high school, and so I did Pascal, Turbo Pascal. So I was, I remember the first course programming class, I aced the exam, I didn't just breeze through the first classes.
Was that more programming based, you mean, or math based, or what type of courses do you mean?
Yeah, so that was just a regular C++, introductory course, and so it was not really that. But then I really was more interested in math, and philosophy, and being deep thoughts. And but then that kind of converged at the end. I got stuck into numerical analysis and in large scale computing, parallel computing.
How did that come about?
It was a strong tradition in Uppsala.
Oh, okay.
And it really kind of, for me, computing things, was really interesting.
And which department are we talking about here that is focusing on parallel computing at this time?
So Now it's called Institutionen för informationsteknologi. But at that time when I started, there was several separate departments, and they were called teknisk databehandling, which is like so they were pioneers.
What year was this approximately?
When I started?
When this department teknisk databehandling existed.
96, 97.
Yeah.
And so they came, with the whole baggage of, the first computers in Sweden, traditional, a long time ago, working with computers. And because of that, they did some of the programming classes. And then there was also departments of computer systems and, datalogy, computer science, that did also some programming. So I kind of, gravitated toward the math-oriented, not the discrete math, but more the continuous math, partial differential equations, solving flows, and I guess a little bit of that was, sound was one of the things got me interested in that. So I did my master's thesis on sound flow through curved ducts. Doing
curved ducts. What does that mean?
Ducts. So basically a trombone.
So
we did a study on what happens when you bend a tube and there's a wavefront coming through it. How sharp can you bend the tube?
Yeah, and a trombone is a tube bent a lot of ways.
Yeah. So there was a guy there who did that kind of attracted me.
And you tried to model that using math as well?
Yeah, so it was very simple. I mean, it was just a wave equation, so it's not super fancy math, but it's more the whole computational aspect. You have to resolve that geometry using a computational mesh, and have to work. So it's kind of like if you have a connection to AI. So I spent my PhD studying iterative solvers for linear systems. Right. So it's close to back propagation, and also this whole optimized stochastic gradient descent, those type of algorithms. So my PhD was around parallelizing those type of algorithms, and that has been done before, but my kind of interest was in how to do that for this type of emerging shared memory architectures.
And if we just unpack that a bit more, so this shared memory, are we speaking more like this kind of supercomputer kind of
so in the mid-90s, actual multiprocessors, big Oracle database, Sun Microsystems type of systems, IBM, they were growing, and they were like multi-socket. So what happened was that Uppsala managed to recruit one of the chief architects of Sun Microsystems, Henrik Löf.
So now we're talking Sun Microsystems. What's their operating system called?
Solaris.
And then equivalent of Solaris you had in the digital world. You had Alpha.
So exactly. So DEC Alpha. And then you had AIX.
AIX is IBM.
And HPUX.
HPUX, right.
So all the RISC platforms. That was the RISC wars,
So if you contrast that, we had the old mainframes, and then we had sort of on the other end of the spectrum PCs.
Yeah.
And here we had this mid-size style.
And it really was pushed by running big relational databases like the Oracles.
Yeah.
And you couldn't distribute them over a network, so they had to be tightly coupled with multiprocessors. So that was really IBM and Sun and Itanium, and there are a lot of interesting problems. And Henrik Löf had been designing those systems, and he wanted to move back from Silicon Valley to Sweden, and so he brought him money and funding. So my PhD was looking at modern emerging architectures, computer architecture, and applying computational algorithms on those. So my thesis was around non-uniform memory access. So what happens when you do multi-socket systems is that you have to do communication between the sockets.
Sockets, you mean basically CPU cores?
Yeah, not CPU cores. This was before multicore.
Okay. This is before multicore.
Yeah, so multicore was, at the end of my PhD, we started looking at multicores. They become, available. Then.
So multiprocessors or something?
Multiprocessors was there was a single core.
Single core multiprocessors.
Now, single core was one socket. So one CPU, one core, one socket. And you connected all of those sockets together.
Some sort of mesh.
Yeah, exactly. So, and, then they all had local memory. And then if data could be placed in either local or in another socket's memory. And if you wanted to access that memory, there became a remote access. It was all orchestrated by a cache coherency protocol, and was kind of built into the system. But the effect was that if you didn't understand, so data could be taken. So it was non-uniform access time to memory. And that's the kind of that's mainstay now. So NUMA type of optimizations is done like on the OS level for all of these computational things.
But at this point in time, the 90s, mainframes, what was OS, gamla IBM mainframe, or what is operating system called? I forget. OS4, I forget.
Not AS400. That was
AS400 is another one again.
Yeah. It's called SED something.
Oh, whatever. Yeah. And then you had, but could you just elaborate a little bit? You said it briefly. There was a new breed of relational databases that was driving a need for a different type of computer architecture.
Exactly. So the Oracle databases, multi-threading came along. So that was really the enabler from a programming perspective, how you could run on these multiprocessors. So the idea is that you have one OS kernel that you can, and multiple sockets and threads. So the programming, you never programmed against processors, you programmed using threads. So P threads, POSIX style threads was kind of emerging.
And perhaps you can just elaborate, what's the difference between having multiprocess and multi-threading?
I mean, multiprocess has also been around, but then you have inter-process communication. Yeah. So you could have sockets is one that we use for networking, or shared memory was another way of mapping memory address space, memory segments to communicate. So,
but in short, you can say that threads basically share the memory, and processes have a different memory, and you have to move the data between the memory places.
Yeah, so I mean, a thread is really just another program counter. And abstraction for that, and sharing the exact same address space as the process. So they live inside that process.
And would you argue for me that it does not know the details here? Was Oracle built as a relational database, and the other relational like DB2s, were they built in a different way, or were you now trying to program them?
No, I mean, it came from, this was OLTP, OLAP, territory. And you wanted to grow and grow the capacity of the database, how much processing.
Did OLAP really exist at that time?
Sorry?
Did OLAP, the online
I think so, yeah.
analytics processing?
The first data warehouse
and
is
this whole Kimball modeling and all that.
That's 18th, 90s as well.
Yeah, exactly, that's late 80s. So OLAP was definitely a thing.
Yeah,
and
cool.
And it was basically...
And perhaps we could just elaborate. OLTP versus OLAP, so to speak. Well, what's the main difference, would you say?
So OLTP is online transactional processing. Yeah. And that's really, microservices or stuff like that.
This is transactions going on in real, when you're doing...
If you have an e-commerce website...
Transactional processing.
Yeah.
I'm going to let him speak.
Sorry.
Yeah. Transactional processing. So e-commerce or what have you, when you capture, online transactions. And the thing was that...
Would you agree that, you can say that OLTP is more for operational type of databases versus OLAP is more for analytical use cases?
Exactly. Afterwards? So the thing is that they run on the same technology. They both OLTP and OLAP run on regular databases. After a while you have Teradata and Vertica and, all of these type of specialized solutions. Kind of like Snowflake today would be an example, but the main thing was that you wanted to isolate the transaction, because the long-running analytical workloads, you couldn't run them on the same instant. So that's where, ELT and all of that came around. You had to move the data off the transactional database to the warehouse where
Did you say ELT on purpose, or did you mean ETL?
Oh, sorry, ETL.
I mean, ELT is actually, people are speaking more about ELT these days.
That's more of a
ETL.
modern Hadoop thing that came later.
Back then, ETL.
ETL was the
extract,
transform load. So, and all of that. I mean, I haven't really worked with BI and in those traditional. I came later on. I came right on the ELT Hadoop stack. That was my first kind of. But I knew databases, and during my PhD, I took a PhD class in databases. So there's Tore Risch, a professor in Uppsala, so I studied like query optimization for SQL and these low level optimizations.
Okay, so just to summarize your thesis work a bit. So you basically had these sockets, and the access to memory was not uniform. So it was different timescales, basically, that you could access.
I mean, in high performance computing, it's all about squeezing the last bit of performance. Yeah. So the systems Erik Hagersten brought with him were a very special system, because the idea was to take an entire server and do an interconnect, a very high performance interconnect, and connect another server to make this a huge, shared memory machine.
Right.
And then you could have a remote access penalties of about 5 or 6 times slower when you kind of pushed over their interconnect. They were all running one OS kernel on kind of over this whole system.
Perhaps we can just, if you try to get an overview of different type of computing architectures in some way, you can think about this kind of mainframe, or you have CPUs and memory being accessed in a large, mainframe in some way. And you can think more big data type of Hadoop type of architectures, where you have mid-level, mid-range kind of computers being connected together, but really the latency between them is much higher than the mainframe type of access. And then we can potentially take the third, which is more AI GPU kind of structure.
So actually that's kind of so that's what I was. So the team Erik put together was a computer architecture team. So it's about how to build efficient software computers. So it was about CPU design and especially around cache memories and memory access. That was his specialty.
So what do you think the future is? I mean, a lot of people still use the term HPC, high performance computing, in different ways, and you can use supercomputers like Cray machines and whatnot for.
Yeah, but I mean, see, the trend now is more on FPGAs or more custom. So we can talk about this for a long time, but you have this Moore's law, where you get more and more transistors, and then at a point. Yeah.
And Moore's law was basically saying that the number of transistor per volume in some way or area was doubling every 18 months or something, right?
Exactly. Yeah. So I remember when back in the days when we were at the manufacturing process of 120 nanometers or 90 nanometers. And I think the fabs today, they can produce like 5 or 7 nanometers.
Yeah.
So, so this has been kind of going on, and we're all speculating where will it stop. But what happens is, like, when you have very large dies with a lot of cores, actually communicating on the die will take time. So even with the speed of light, if you have a certain size, and that led to, you couldn't build these monolithic CPUs where you use all the transistors for one big core. So you had to partition them into multi-core processors. So that was, the main driver. And I think that what we see now with Apple and the M1 CPU, you start building more and more accelerators and custom hardware. That was also, if you go back to 386 and those type, we had an external FPU and
Amiga at your time.
Exactly.
Amiga had what was it, Blitter or Blipper?
The copper and the Blitter. Yeah. So different co-processors, basically.
So you're basically starting to optimize the computer or hardware to do one thing really, really
well. Putting hardware acceleration. And, I have one of my friends from that time, Zoran Radovic, he's working now with Samba Nova, which is an interesting company that basically take a PyTorch graph and renders it in hardware to run it basically in hardware using.
So basically, you do FPGA for the specific kind of model, and you just print it, so to speak, on FPGA.
Yeah, or some way of really optimize it for AI type workloads.
I saw something about the upcoming Google Pixel 6 phone, and they started to launch their own chip now as well, a tensor chip, so to speak, that they put in the phone, which is replacing the Qualcomm kind of chip that otherwise is dominating all the mobile phones that we have. But I think we can see that the increased specialized type of CPUs that they have there. I think they have the normal CPU, the general type of processor, and then they have GPUs. They have some kind of DSP, data processing unit as well, I think, and then they have the TPU, tensor processing unit kind of thing. And they all have different purposes, and there seems to be an increasing specialization in different type of processors.
Basically, you have a larger and larger transistor budget, but you can't make one stuff bigger. You have to just put in more things and making them work together. Yeah. So it's really, if you talk mainframes, then you had like a CPU board, and then you have the memory, and it was really distributed. Now everything just shrinking. So now a mobile phone fits on a single chip, the system on a chip type of.
But the trend here really is for specialization in some ways, because it's
miniaturization and trying to it's always been about what type of workloads are important to sell the chips, and then try to support those as best as possible. And the last 10 years it's also been a lot about saving power.
But if I throw in a curveball now, so Elon Musk is now producing chips with the use case application in mind. So he's taken the specialization of the hardware infrastructure all the way down to what do I need to do when I do autonomous driving. I think that says something on the trend. What do you think?
Yeah, I mean, if you look at Apple, for instance, they started buying CPUs out of IBM and now the power. Then they moved to Intel, and obviously Intel couldn't, keep up with the innovation. And now they made a really smart move, starting their own chip manufacturing, because they can customize them for their software and their ecosystem. And now they're ahead.
It seems everyone is starting to produce their custom processors now, or it's starting to become an increased.
Yeah, I mean, it's type. Also the other trend is then the movement out of x86 Intel to ARM, ARM is more of an open.
Could we go back? What is the difference between Intel?
That's the instruction set architecture, basically.
Yeah. And ARM is a different.
Yes. So ARM came out of the embedded world, like smaller type of CPUs for not for personal computers.
So the legacy starting point is different, and then all of a sudden, when you start going down and down and down, this starting point is maybe better.
Yeah, so the M1 is really the first, Apple, that's an ARM-based chip. So you have to, recompile all your code and, and that's the third time Apple does this, big binary transition.
So binary transition, what does that mean? You need to recompile everything you build?
No, so Apple has this translation layer now. So you can run x86 code, but it gets translated into ARM code.
Cool.
And it's really, fast and transparent.
But speaking about the general problem that we have, NVIDIA, of course, is very dominating today, especially when it comes to GPUs and AI. And they have their own GPUs that is completely dominating. And this is a potential problem. And we can, though, see that more and more other companies are starting to produce GPUs similar type of processors. But then NVIDIA bought ARM.
Exactly. So, right? But so ARM is more of an intellectual property company.
Yes. Are you scared about that NVIDIA bought ARM as well?
I'm not in that business anymore. And honestly, no.
But if you phrase it like this, NVIDIA was dominating the server space in some way, and the GPUs for AI, data clusters in a large extent, but they didn't dominate in the mobile phones in a large extent.
No, NVIDIA, there was just luck, So I was actually part of the first. I did a class in 2000 in Norway where we talked about GPU programming, general purpose GPU programming. Because
this is early, right?
Yeah, and the first real commercial chip was the Cell processor that was powering PS3, the console. And people were kind of wiring up these. And then I think at that time CUDA came around, the first like framework for doing this type of workload. So, knowing my history, this started with the thinking machines in the 80s, the connection machines that has the same type of SIMD, single instruction, multiple data type of architecture that some GPUs also kind of work. So it's an old way of working, but someone came up with the idea that, okay, all this texture processing is really a SIMD architecture. And then you could, but in those days, no, you didn't have proper floating point support.
So SIMD is basically single instruction, multiple data.
Yes,
right.
So, yeah. And I mean, the connection machine had 65,000 one-bit processors. So it's kind of an extreme version of that.
Yeah, we went down a rabbit hole here again, but I think it's interesting to have some low-level
could we
stuff.
Go up from the rabbit hole? What did we see? What can we conclude from this rabbit hole? What
do you think about the future of like computing architectures?
For me, it's just a substrate. I don't really think about it. I don't say it's a solved problem. But for general purpose computing, it's just, low power, low costs, and, the whole distributed way of working has really won. So the whole shared memory, there's not so much demand for these big shared memory systems. And obviously, if you're compiling stuff on your laptop, they're running on 8 or 6 cores, and
But the old mainframes, are they going down more and more? You would say?
I don't think you can sell a lot of these like 128 socket, big ass machines anymore.
Yeah,
but it's an interesting topic then, to digitize or AIFI Europe, HPC computing versus GPU computing, and it's clearly decentralized. It's clearly GPUs, and still we are spending a lot of money in other types of technologies.
That said, if you look at an AI algorithm, it's not like they're paralyzed. It's more like you have a parameter scan, and you run many problems on, but it's never that you do a backwards propagation in parallel over, compute cluster. I mean, that's a very hard problem to accept. It's more like you can use a cluster. It's more like embarrassingly parallel. So you run
unless you do GPT-3 kind of stuff, then you have to split the model as well.
Maybe, but that's more really advanced stuff. But I mean, the application of, as I understand it, AI is kind of far from what the HPC community is doing when you take one big model and parallelize it on a cluster.
Yeah. So that's a bottom line. If you truly understand the core computational problem of AI, the applied AI, not what we're doing, it sort of points in a direction to what type of architecture would suit that. And are we saying are we playing in the right, or are we investing technically in architecture that is not really the most optimal?
Are you speaking about EU now?
Yeah, maybe.
Then I would say yes, but let's not.
Let's not go there.
I mean, the whole. I mean, right now we're in an acceleration phase, so the libraries, bottom line is it's matrix multiplication that a lot of deep learning is doing, and so you accelerate that to a point, and you can do it in hardware and whatever.
But because what I'm saying is, if we truly understand what that is all about, then we could say what type of technology, hardware architecture fits that problem best. It's not that rocket science to see what is matching and not matching. In terms of what hardware types should we really be better at?
But it's just like, even if you could understand this, building that chip, building a chip is like several $100 million investment, getting it to work. And so that's also where this trend of FPGAs comes in, because then they're becoming more and more powerful. And then
and what is FPGA?
So it's like field programmable gate arrays. So
what does that mean? What does that do?
It's a kind of a template chip.
So you solve something.
So you can kind of program the chip to do things. So it's a normal CPU. You kind of hard code everything and you manufacture it.
Awesome. And if we try to, we can continue this talk.
Get out of the rabbit hole.
Let's try that. Okay, so you made your PhD. If you were to summarize in one sentence, if you could, what was the main contribution you would say from your PhD work? Some conclusion that you could phrase very briefly.
It wasn't really, PhD in science, the only kind of we studied, one of the problems was when you start up a program, you initialize all the data. And what happens then is that most operative systems at that time and still, they use the first touch policy. So basically, the first time you touch a page or some memory, get bound to that CPU or that memory where it was touched. So if initialization is serial, when you start up your program, and then you start up another threads, they get scheduled to the other cores.
Right.
They will get a lot of remote accesses. So what we studied was a way of redistributing the pages. So we studied that.
After the initialization, you can redistribute the
exactly.
allocation
So
to them?
it's technical, but you have a transaction local site buffer, a TLB, and that controls the paging. And what you could do is you can reset those mappings and then reallocate those pages. So when you do that, there's a penalty. So you have to move the data. But you have a long-running computation. You can amortize that initial cost.
So ultimately, what you're trying to do is you're trying to be smart to remove as much as remote access memory.
The real what we wanted to do was have an intelligent system that could measure remote accesses and move pages where they would be suited. In a kind of optimization problem.
Awesome. What happened after your PhD?
I did a postdoc
at
Stanford University.
What did you do then?
So it's also kind of So
and Stanford is one of the premier universities in the world, right?
And even in this field, premier, I would say, close to Silicon Valley.
Yeah. So my work was with. They were called petroleum engineering at that time. And now they're called energy resources engineering. So my department had contacts there, and basically they wanted me to come and teach a class.
Okay.
So I was teaching like high performance computing programming. Writing fast code.
That's super cool.
Because all the students these days, they learn Java or Python or something, and that doesn't cut it when you want to do high performance computing. So you have to learn, C or Fortran or something. So that was, and then, there was also an opportunity to do research, parallelizing algorithms. Like that was my trade. So I did a combo of those.
Cool.
And when was this? How many years were you in Stanford?
It was just, 1.5 years. So it's between 2006 and 2008.
Then you took a step into the industry in some way, right?
Yeah. So
how did that happen?
I came back to Sweden for private reasons, basically, and personal reasons. And then I ended up doing a research project at my old department. And then I was looking for work. And then they were called BEA web system. So if you're familiar with BEA, WebLogic was their kind of core product. Middleware, application server type of thing. They had acquired a Stockholm startup called Appeal Virtual Machines, basically to be able to run their stuff on the Itanium CPU. So Sun Microsystems, who own the JVM space, they didn't want to build a JVM for Itanium. So Intel made a deal with Appeal to, they've started out building a virtual machine out of KTH, a very talented team. And then they got funding from Intel, and that bootstrapped that company. They got a working product, and they were acquired by BEA, which in turn went acquired by Oracle.
Oracle, yes.
And then Oracle acquired Sun. And then the original JVM team was merged with the JVM team at
and Itanium was Intel-based architecture, right?
Yeah, so it was a very special type of kind of a do-it-all
But how was this sequence? I mean, like BIA bought by Oracle, Oracle bought Sun. In what time frame is all this happening? Because this is
3 or 4 years.
It's quite fast, right? A lot of
I don't know when
Appeal
was acquired. That was before my time. But the Oracle acquisition happened during my tenure there. I was there for 4 years, and during that time, Oracle acquired BA and Sun was acquired.
And could we, because I used to sell Sun machines, you see. I was working at Mercantil at the ATIA today. And we were selling this is 99, right?
Yeah. So in Uppsala, we were on a few who had a Sun Fire 15K, for instance. You may remember
super
that
cool
model.
stuff. Yeah. And we were selling one of those big boxes, some of them. The ISP, the internet service provider, they love their Sun Solaris boxes. Anyway, they were the shit. What happened? So, something happened a couple of years later that allowed Oracle to acquire them, because they would have been really expensive to buy in 2000.
Yeah.
Because there was a little bit like everything. Solaris was really up and coming. But do you think did something happen? Was it a story behind here, or is it?
There's been a lot of good writing about the demise of Sun Microsystems.
That's what I'm talking about.
And to be honest, obviously my old advisor was, chief architect at Sun, so he has a lot of baggage there. And my project was sponsored by Sun as well, and I came along. Obviously they underestimated the whole web trend, so they came out with, and they made a couple of big mistakes, but they bet on after the UltraSpark 3,
which was great, and they spent hundreds of millions of dollars on CPU programs that failed. So there was the ROC processor and the UltraSpark 5. And basically, Intel caught up, and the demand for these big multiprocessors was, now it was about multi-core chips. Multi-core instead, right?
So there was another product line with Sun called Niagara, which was more leaner and more heavily threaded for kind of ISP web workloads. And that was the surviving product line.
Cool. And then you started working for Oracle for a number of years. And can you speak a bit? What was the main focus?
So I started in the what's called the sustaining engineering team. So we were doing critical customer escalations and hunting down bugs. So a Japanese bank could call us, and I've been running this workload for 2 days and it crashes. What's wrong? And so I was digging through core dumps and log files, trying to correlate, finding what was wrong. And then we made.
And this was on Java-based systems, right?
Yeah, exactly. So that was on the Appeal virtual machine, not on the hotspot in the Sun. So it was called JRocket, was the product name.
Right.
And so we ended up, analyzing and fixing and releasing. So we made a patch on the JVM, or sometimes we did ourselves, sometimes the engineering team did, and then we released that. So it's a lot about those type of work.
There's a lot of high stress situations, that big systems.
So you were sometimes called into meetings with customers, and they were all usually very pissed. And then after that, I moved into the performance team. So we did a lot of performance testing. So very important to have no performance regressions or a consistent performance for every release of the JVM. And I was on that team when we merged with Sun, and that's where we, at the end we did a lot of work on the G1 garbage collector. It was kind of in development at the time.
And what is a garbage collector in the Java world?
So garbage collection is a kind of a tool to help you manage memory. So the idea is that you just allocate memory, and you never bother about releasing it. So the role of the garbage collection is to understand if memory is used or not and reclaim it. As if you program, say, C++, you have this new operator and delete operator. So you have to, if you don't delete your memory, you will have a memory leak and you will run out of memory. So that's the whole point of a virtual machine is to manage both the, write once, run everywhere, bridging the hardware, and also manage memory. And so the holy grail for garbage collection was really to make it as lean as possible and not interfere with your, everybody running, early Android phones, remember, suddenly everything just froze, and that happens as well, sometimes, not so much these days.
And frozen basically means that the phone went into some garbage collection mode and it went through all the memory.
Exactly.
It takes seconds sometimes to
and now I don't remember the name of it, but the guys now, they have done this, completely concurrent GC, which was, a very big technical.
Is that a CMS thing or was that something else?
No, CMS was the early one. So G1, it's a new one, ZGC, I think the project is called. So it's completely concurrent. So it reclaims memory while your program is running. You can remember in a Java program, if you have a linked list, you have a reference to nodes.
This is a big deal. This must have been a big deal to solve this.
Yeah, and if you kind of remove one of those nodes, you have to release that memory, but you have to, the system has to do introspection and see that, okay, this is not live. So it's extremely interesting subject in itself.
I mean, it's a research field in itself, right? To do this in a concurrent way, I guess.
Yeah, so I think it's like a holy grail to have a completely concurrent GC. It's like a big technical breakthrough. And now the problem, it's not if generational yet, if I understand it. So they want to, that's the next hurdle.
Yeah, generation. What was it? It was called like young, old, and permanent or something?
Yeah, exactly. So
what was it?
It's all of this memory type of thing is all about exploiting locality. So in a lot of programs, you generate lots of data that is released very quickly. And the idea is to store that, or keep track of those in a special generation. And if objects are referred to or are live, they get promoted to old space or some other space where you have another type of algorithm. So it's just an optimization based on an observation that there are a lot of short-lived objects.
It seems like a lot of custom heuristic and hard-coded rules to do garbage collection. Sounds almost like a perfect application for AI in some way. Don't you think?
I think the timescales doing predictions on AI, we're talking about, has to be extremely efficient. And also you can't do a mistake, you have to be very accurate. So AI, doing fussy predictions and, I forgot 80%, effective and leaving 20% of objects behind is not really.
Well said. Cool. That was sounds like a really amazing things, being actually part of, making patches to the Java virtual machine itself. You must have learned a lot, I guess, from those days.
And expected it was also a extremely talented team. So it was really grown out of KTH, that generation. Lots of very, very good programmers.
But is it a Swedish team or is it a European team?
No, Swedish team.
But you said you're supporting a Japanese bank. But was it more for Swedish customers, or were you working worldwide?
They sold their products internationally, and so they had to ramp up.
But it has to do with the startup in Sweden.
Exactly, they started it, and people like Sten Garmark, who's now the head of product at Spotify. He was the development manager at that team. Yeah. And so there are a lot of
all the people, the talented team that you work with there, you can they have all gone down different
paths. A lot of us went to Spotify. We were recruited at some point, and most of those people have, and some are still at Spotify. But
let's take that step then. How did you get into Spotify?
Well, it was basically headhunted, in 2010, 11, something.
So someone came up to you and asked, we're doing this, and what was your initial, type of work that you did at Spotify at that time?
It was really actually interesting. So I came along with the Facebook integration. Oh, right. So I spent my time in that team building that integration with Facebook.
But do you remember, like, what was the appeal to go to Spotify? I mean, like, what?
Well, it was really more about after the Sun Microsystems acquisition. My manager was on the West Coast in the United States, and I had small kids, and I didn't want to work at 9 p.m. every day and sitting in meetings.
No.
So I think it was more that situation. I wanted to do something locally here in Stockholm. And also, of course, interesting. I mean, again, I'm passionate about music and collecting records, exactly. and so of course building a music service was.
So working with your core competence, combining it with your core passion, that is cool.
I mean, a lot of the early people, of course, with Spotify were passionate about music.
Which I think is one of the points on the secret sauce, isn't it? I mean, like Carl Tomé, music, and some other guys.
It wasn't part of Spotify though, and I had a horrible taste in music as well, but I still worked there. Anyway, okay, so the Facebook integration, I think a lot of people don't know about this part of history in Spotify.
No, it's really interesting because, I mean, Spotify was on the verge of, extinction and dying. They weren't growing enough, and then I don't know all the details. I have to ask, Gustav or somebody how that works, but apparently Daniel Ek struck a deal with Zuckerberg to basically, it was about onboarding new users. So the idea was to post music on the Facebook feed and get people to click and then, download the Spotify client and, create more users. So that was then, it was, extremely complicated flows connecting, Facebook and Spotify. We had these double accounts and,
And more or less a one-click place from Facebook as well, right?
Yeah, so we tried to streamline that flow. And you remember that time we didn't have a good web player. There was no mobile client. So everything was, optimizing the download of the desktop client, which was like an 85 megabyte payload. And so we did, you could see people dropping off, waiting for the download. And then we had to make the track they clicked play, install the app, boot it up, create the account, play the track. So super hacky, a lot of hacky things going on.
So we had a lot of accounts that weren't. I guess it was a lot of problems trying to maintain all these kind of accounts being created, right?
Exactly. So what happened was I got basically left with the whole login system with Spotify. So I was kind of system owner for the login system, accounts and everything. And so basically ran the whole thing myself with support of two of the guys who built most parts of the system. So it was like, if you couldn't log into Spotify, they called me. That was the deal. And, very, very stressful time of my life. But it was also very interesting because you get, everybody needs to interact with the initial bootstrapping and so we were another guy who ran the whole access point. We were like the two people who controlled the central nervous system of the whole system.
And when we're talking about login now, you can both log in based on your direct Spotify login, but then you have this log in with your Facebook ID and stuff like that.
Yeah, but
that was part of
exactly. But that's like common ground now with OAuth and those type of OpenID Connect flows. So Facebook was early on
fixing that.
Yeah, so it's not it's standardized more or less.
But was it standardized then?
No, I wouldn't say so. And we had secret backdoor APIs to Facebook to solve some of the problems.
It was a really close collaboration, I guess, at that time, right?
Yeah, and I remember the launch. I mean, especially remember one of the Zuckerberg held this demo and where he was trying to introduce this integration, and everything was super flaky and not really ready for production. But we wanted it to work, and there was this hiccup just before he was supposed to go on stage, and everybody was panicking. But somehow we managed to.
You fixed that, and then actually the demo went well.
As I remember it, yes.
So it did go well with the actual demo.
I know. People were sleeping at the office. It was like,
Cool. I can see we would have spent an hour when we haven't really moved into Karolinska University Hospital yet. So let's try to move a bit faster, I think.
But we have several cool topics in Spotify. I mean, like you were for one, you were there when they moved to GCP, right?
Exactly. So
that's an interesting topic.
So actually, if you talk about data, so we had this, Europe's largest Hadoop cluster. Anders here was really
destroying
it with running Spark on it. It was clear that this was not sustainable, and we were actually running out of, electricity in some of our data centers. And we had to do something.
Not memory, electricity.
Yeah. Or, it became not very economical at that point. And then, there are a lot of good architects, and we talked, I guess, with both vendors at that time. Amazon and Google was just starting up. Azure wasn't really a thing.
But we actually started on Amazon, right?
I think they tried
on-premise and then to Google, right?
I don't remember the other days, but as far as I remember, we always had our own data centers.
I think we started on Amazon.
All right.
Doesn't matter.
And then Google was interested on onboarding a big international client.
They were hungry.
Yeah, on GCP, and Spotify became that client.
Poster child.
Yeah. And I wasn't really part of that whole migration, but I was one of the first people using BigQuery. And so that was a real revelation when we, came on to BigQuery, and coming from Hive, it was like a godsend.
And perhaps we need to explain a bit what Hive and BigQuery really is. But how would you describe the two in a brief way?
Yeah, so Hadoop came out of a programming model called MapReduce. It was not really, Luigi, the system we had for it, made it accessible through Python, but you still had to be thinking about, keys and values and, reducer. And, for me, came from a parallel programming perspective, that's like, no problem. I could get
this was your home turf.
Yeah. But it was really, at that point, Java, Hadoop, output, input formats, really complicated work, broke all the time. So Hive was just a way of bridging, a SQL layer on top of, so basically generating MapReduce jobs to run SQL queries.
So Hive is to simplify it, isn't Hive some sort of that, if you want to run a warehouse style or OLAP style stuff in Hadoop world,
it's to make
Hive is one example.
Yeah, so Hadoop and HDFS is all about file-based access. So what Hive does, if I understand correctly, is just create the metadata to form tables around those files, and there's some caching, optimization, and things going on.
It's like a compiler to actually produce MapReduce jobs.
Yeah, I think it's kind of evolved a little bit now, but it, you gave birth to all this, Impala.
Yeah. Cassandra, Impala, Hive. What's the difference?
Cassandra is more of a storage thing. But so, and then BigQuery is basically the same thing.
Like Hive. Yes.
It has BigQuery has. I think that's gone now. But at that time, you couldn't just run BigQuery on top of an object store like GCS or S3. You had to import the data to a special columnar format. Optimize it to be able to run queries. So it's, in that sense, it's kind of like Hive. But I think now maybe you might be able to run it directly on top of...
You can, but that's really slow if you do it like
right.
that. But in short, it's like 100 or 1,000 times faster than Hive almost, right? For the same type of data?
Especially the latency was really impressive. So you can breeze through terabytes and terabytes of data in 10, 20 seconds.
Yeah. Almost petabytes of data sometimes.
So it's really parallelized, and basically, Snowflake. What Snowflake does today, BigQuery was, Redshift was another product from Amazon with a similar. It was more cumbersome to work with because BigQuery was also schemaless, which is another important aspect. Redshift was not, if I remember it.
Yeah.
So
it's more relational based.
So you can mix, schemas in the same table in BigQuery and still query it.
Yeah, really cool stuff. And if I remember correctly, it also BigQuery is this kind of hierarchical system where you have some leaf servers doing the low, what do we call it? The first kind of data processing, but it's being aggregated in a number of steps before you actually can answer the SQL query that you have.
Yeah, exactly. So that
proposed it.
We did that in high performance computing. It's called a tree reduction. So it's like a log n type of algorithm. But with BigQuery and these systems, you can also do what's called predicate pushdown. So if you have a where clause, a filtering, you can push that down to the leaf node, and then you get a massive parallelization of those type of, especially if you're doing joins and things, you want to filter down your input data before you do the join. And that's where these columnar stores and predicate pushdowns come.
Becomes very powerful.
Yes.
But in short, you can say, moving from on-premise to Google Cloud in general for Spotify, one of the biggest benefits was BigQuery. Would you agree?
I would agree. I mean, at least in the beginning, because I left when, services were being, I think the other one was the hosted storage. I don't know what they're using today. And they were discussing using Spanner, but, Google, those type, instead of operating Cassandra, which was the, bread and butter we had, there was a lot of pain keeping it together. So, but I mean, maybe they were looking into Kubernetes and these type of things when I left. So I don't know what they're running today,
but in the beginning, a term that you have used and we have used quite a lot is lift and shift. And in the beginning, it was basically trying to lift and shift, saying, we have Hadoop clusters running on premise. Now we're running Hadoop clusters on Google Cloud, not really transitioning to the Google Cloud services, but just, moving to the virtual machines.
The whole ingestion pipeline was really, the whole pub subsystem of GCP was also extremely beneficial because we used to run these large Kafka systems, ingesting, all the logs, everything the clients, millions and millions and billions of messages. Yeah. And with the pub sub on GCP, now I'm making commercials for Google here. It actually was a big step forward in terms of having that hosted and managed, and also data flow, the other thing.
I mean, doing the data flow, which they, to my knowledge, are doing much more now, after actually doing the lift and shift first to just run Hadoop on Google Cloud and then actually shifting to data flow where everything is managed for you, of course, is a big benefit. But it took some time to, as far as I remember.
Yeah, and also, the whole, don't forget also the whole GDPR compliance work that Spotify has to go through. Also work.
Yeah, I'm eager to go to the safe harbor kind of problem, but let's not go there yet, perhaps. Okay. Any other highlights from the Spotify days that you'd like to mention before we move into Karolinska University Hospital days?
What I remember is just the whole environment there. With lots of, of course, there was so much money flowing through the company, so you could spend. There was no limits, If we want to hire 100 people, we hired 100 people.
Or I remember one member in our group as well that ran this super duper machine on Amazon Cloud, and he never used it, and it was like twice his salary per month in cost, and it was just running there. No one really knew that it was running there. They didn't care that much about the cloud costs.
No, it was just grow the company, So that was, and then, but it's most of the people you remember, the colleagues and, things you did.
But there is a quite extreme growth phase. This, so you were saying some numbers. How many people was recruited per week? So there's also something living in a company where you have that, because that has a lot of implications.
From what I remember, there was the whole New York Stockholm divide. So we were divided, and it was really, in some sense, especially on the data side, a little bit of a conflict, the US people.
Competition or conflicts
on how to solve certain problems. and also of course the Swedish versus US culture on managing and doing things. And so I don't know, but from my perspective, Spotify got more and more Americanized, and more governed, especially after the stock introduction or the IPO. And also for me personally, I was mostly interested in the music experience and making a good product. So I spent a lot of time on the catalog pages, the artist pages. So I one point I produced all the top charts on Spotify. That was me doing those, putting together the charts. So I was kind of into the whole album experience, and you quickly realize that that's not where the money is, and they're not going to prioritize work on improving how Tchaikovsky is. If you search for him, you get the perfect experience. It's other things. So that was one of the reasons I was kind of done with the whole thing.
Yeah, and you were there for a long time, like
7 years.
7 years. Yeah. Cool. And how did you get in contact with the Karolinska University Hospital?
Yeah, so I was kind of looking for other opportunities, and I decided I wanted to do more. I was looking into climate or healthcare to do something
meaningful,
completely different, and have some more purpose. And then I ended up seeing an ad where they were looking for architects, and I thought, why not?
And what does an architect at Karolinska actually do?
Yeah, so I mean, what I've learned is in public government or public sector in Sweden, architects are usually, in a lot of places, you're dealing with mostly about buying products on the market and then putting them together. So, and also governing the whole integration aspects, writing requirements and testing and, piecing together. So it's more about kind of tying together and heterogeneous.
Having the holistic view of everything fitting together in some way?
Exactly. And there are different flavors of the architecture role. There's also some amount of strategy involved. There are the enterprise architects of the world, and they're more into strategy and business values, and there's also very formalized frameworks, TOGAF and what have you, or frameworks of dealing with architecture. So it's kind of I never done this type of work, and I was a little bit interested in what it meant, and I picked up a few things. But what happened with my situation is that I'm much more operational and actually working more with solutions and building things, designing things.
Are you also coding these days? Or?
Yes, a little bit.
Very nice. And just to
was this your choice?
Yeah, so I mean,
this is not where this is happening. We need to go more concrete.
So it was part of a strategic initiative or bet where we really wanted to be more hands-on and gather more actual knowledge of IT in general. So Karolinska has had a BI team, data warehousing team for a long time, and which is really so the hospital has been doing data driven. It's very data driven in a lot of sense when it comes to producing healthcare.
That sounds really interesting, and I want to explore that a bit more. But let's just speak for people that don't really know what Karolinska University Hospital actually do.
Yeah, okay.
Can you speak a bit? How many people work there? What are their specialities? How does it relate to Karolinska Institute or something?
Exactly. So Karolinska Hospital has been around for 100 years or so, 150.
Oh, really?
In different forms or shape. It started out as a military hospital.
Okay.
But it's really the largest hospital in Sweden. So we have 2 sites in Stockholm, one in Solna, NKS, Nya Karolinska, and in Huddinge, called Huddinge sjukhus, but it's the same hospital. And since a couple of years, we have a mission that's called, we are supposed to be highly specialized healthcare.
Okay, interesting.
So, you remember maybe the reform in Stockholm with nära akuter, and so they're trying to differentiate the kind of healthcare workload. So Karolinska we do a lot of things. We're the only place in Sweden where you can get certain types of treatments.
Right.
And also,
can you give some example of what they're?
No, not really, but it's more of these rare diseases and, very complicated procedures, especially surgical procedures that requires expertise.
Cool.
But then we're also a university hospital, so that means that we, train a lot of doctors and nurses, and also do a lot of clinical research. So there's a medical university called Karolinska Institutet, which is just across the street in Solna. And they're a medical university, so they train doctors and do medical research. And a lot of the senior professors are also physicians at the hospital. Right. So in a typical sense, all like the clinical trials when it comes to medication or new ways of treating or trying out, they are performed at the hospital. And we do publish a lot of things. It's really a research, close to research.
Right. And if we just compare a bit to the AI world a bit and the research being done in AI, that is to a large extent being moved into industry in some way. The tech giants performing a lot of the research, and the normal universities is diminishing in some ways at least. Would you say the same applies for medical hospitals? Or?
No, there's always been the pharma industry, and this is really not my specialty. Okay. But there are a lot of pharma industry and new types of treatments. Of course, they need to try those, especially these highly specialized. There are really advanced new treatments coming out where like one dose could cost 5 million kroner, like for advanced cancer treatments. So it's but I wouldn't say clinical research is very much focused around the medical universities. So that's so KI, the institute, is ranked number 6 in the world, I think.
Oh, really?
That's really, really good.
And the hospital is number 7 in the world, according to Newsweek. So
it's really impressive.
So we're number 3 in Europe. How they measure this, I don't know. But
is it publication based, you think, or?
I don't know how it's outcome based publication. This Newsweek doing these type of rankings.
Yeah, we should be proud in Sweden. Yeah. We have surprisingly good universities and companies in Sweden compared to Europe and the world actually.
But my dad is a doctor, but also
medical doctor,
but he's also a PhD or vad heter det sen då? Docent, but in physiology. So he did both. And I always understood that I think here is quite different to AI and that type of research, where I think there's one trend where I think the hospitals play a quite large role, and these institutes that are closely connected to the hospital. Because like you have the Hopkins, you have several, like where the real medical research is done is always connected also to a hospital.
But there are two important things. First, a lot of the data used for AI is produced at the hospital,
right?
Because we treat about 10,000 patients a week at Karolinska, and a lot of this data is manually produced, typing in diagnostics, and takes a lot of time. And the other one is that if you want to validate something to be used at the hospital, usually that happens at the university hospital. So we really in the center of trying to, the whole, if you want to apply algorithms for real.
And it's hard to open source, so to speak, these data sets, I guess. So
exactly. So and that's I mean, if I understand this correctly, so medical journals in Sweden are allmän handling, which is a little bit weird.
Yeah.
So,
weird.
but they're regulated by secrecy. So anyone really can get their own medical record. And also when you do research, you have to go through an ethical approval.
Right.
And then we also have to do what's called a menprövning. So if we have to do an integrity check to see if your integrity could be somehow harmed by releasing data. And this is a real problem for us because especially with AI, we can get these requests. Somebody, I want to have, breast radiology images, everything for the last 15 years, and we have to go through basically manually to make sure that we don't release sensitive data. And so it's an extremely, cumbersome process. And it's interestingly enough, not something we are, equipped. We just do it, and it takes a lot of time for us.
But here we have an AI sorting. We have new technology. I mean, I hear it like Spotify. We have so many recruitments. So we need to automate. We need to systemize the whole process. This is a very natural step for a tech company to start with tech solving a problem.
Yeah.
But here we have typically a problem, right?
Yeah.
But we should throw, and do we throw tech on it? Like use the
I mean, the problem here is that we have to understand that this is what you call secondary use of data. So most of the data produced at the hospital is for, treating the patients. It's about documenting what you've done. So the next doctor can understand what happened and, that the patient's safety is the primary concern. And sometimes it's just free text and, it's not very structured. And this is then we come into medical informatics and about how to structure this data. But remember the old handwritten medical journals, it's really about documenting. And then when you can't just take that data and, understand it, you have to understand the context. So a lot of the stuff we do is we take a request from a researcher and we try to understand just finding the data in, we have 200 systems, where is this data and, how is it formatted, can we, get this data? So it's very, very complicated. But I do know there's a guy at Stockholm University who is doing NLP for the identification of medical journals.
Oh, so like anonymizing
So trying to find personal identifiers in free text.
Right. That sounds super important. Awesome. And before, I'd like to move into the data-drivenness of Karolinska. But before that, I think we have to spend some time on the whole Corona part as well. You were there during the Corona years as well. Did you notice that in some way, or were you luckily disconnected from it? Or
I mean, it was really, for my colleagues working in the wards, clinical. That's really tough. I mean, for us, we didn't notice. We tried to do what we could. There was a lot of buzz in the beginning around, the safety of the masks and everything, and so there was a little bit of support there for us to sort that out. And then there was also a little bit on setting up the testing and making sure. But it wasn't. I mean, some of my colleagues worked more than others, but me personally, I wasn't that.
Okay. So you weren't that affected? Okay.
No.
Yeah, interesting. What do you think in general about Corona? Do you think there will be no more waves, or what's your take on future Corona impact on Karolinska?
I mean, this is a disease we have to live with now. So at Karolinska, it's just, there's no special treatment anymore. It's just one of the diseases that we have to deal with.
Right.
This is interesting because we have in this way, we are sort of in a new normal. We are not in a pandemic mode. We're in a new normal mode.
Yeah, I mean, at the hospital, they deal with other types of, regular flus and, lots of different diseases. So,
but it's nice to hear that Corona is starting to become like a norm, or it started to become a not an exception to the other type of diseases that we still have.
Yeah,
right?
but it's still a problem, in the society if you're, unvaccinated. Yeah. It's not a good thing because those are the people we see coming up, being hospitalized. And so, but this time we got lucky, the next time it could get a lot worse in terms of, the how it spreads and, the effects of it. And there's still a lot of interesting research on the long-term COVID and this type of what happened, and there's going to be lots of research activity, I think, afterwards.
Do you think the whole, rush to vaccines for corona was rushed too much, so to speak? Do you think there will be some kind of unforeseen effects that we are going to see?
No, I completely trust these guys. I think that if I understand correctly, the theory, understanding the virus, that was just a week's work, understanding, okay, this is how we fix the vaccine. And there's just compliance and going through manufacturing. So,
So you're not actually that scared that this was rushed. It was actually, the hardcore problem was actually solved quite fast in terms of understanding the vaccine.
Medical, it's very rigorous, this whole process.
It was a 10x kind of time frame.
Yeah, but one interesting thing happening at the hospital was that it was more of an all hands on deck experience, which brought the hospital together.
Right.
Because we all had to dig in, and and hospital we enter war mode.
Yeah, for real.
So basically, when it was at the worst, it's called stabsläge or whatever. Exactly. Then there's just one guy controlling the entire hospital. So all management, is shortcutted. It's just to be extremely efficient on a day-by-day basis to use
military style.
Yeah, military style.
Set up the talk.
Yeah. So that was, I wasn't part of that to say, but it's still one of the effects now is that we want to keep parts of that
efficiency in decision making.
Exactly. Working together and being more, working together more as a hospital.
Interesting. So, okay, moving back to the topic about being data-driven, and I guess, if you try to compare perhaps, Spotify and the way they are trying to be data-driven, and I think that they are, rather good at that compared to a lot of other companies in Sweden, at least. If we start with the question, basically, what is the difference of being data-driven in a university setting compared to, or like hospital setting, compared to the Spotify setting?
Well, first of all, a modern hospital is more of a factory or a production line. It's about, you have inflow of patients and, you have acute care coming in, and then you have elective care where you're booked. And it's really about managing the wards, where to put people.
Right.
And also keeping track of costs and efficiency, scheduling personnel, all the, resources, medications, operating theaters, sterilization, logistics. It's a big production line, and on the same time we have to take care of patients, the human caring part. So
could you phrase it like you have some kind of plan and some other more acute unplanned treatments that you have to perform? And
exactly. So if you have a big trauma, car accident and you need treatment, you have to have standby, and so it's very, very, very complicated, and we are struggling to understand how to do this efficiently, and I think data could be interesting here to see patterns and understanding, and also things like there's been a lot of one interesting metric is like length of stay predictions.
Cool. Length of stay, yeah.
So if you want to know if a patient comes in, how long time will they be in the ward?
Is this for planning from a logistical point of view? How many?
Exactly. If you know when a person is likely to be discharged, you can plan for that and make predictions.
Right.
So I'm not saying that we have that in place, but it's one of those metrics you can look at, just as a simple example. And
today, would you say it's more like intuition or experience kind of based kind of predictions?
Yes, I would say
I'd just like to add like a Spotify metaphor here, and I think it could be interesting to see how that compares to hospital case. But I remember one point in Spotify, we sat down a number of product people, like 30 of us, and then 20 of us, and then we were presented with 30 different A/B tests. So in Spotify, we of course did do A/B tests all the time to try to see if a change in some kind of product will improve or decrease the user experience in some way. And then we were presented with these 30 different A/B tests, and we were to guess as people at that time, will this A/B test be an improvement or a decrease in user experience? And then we were presented with a case, and we measured, how many people guessed the right thing. And you have 50-50, chance to guess the right thing. And I was assuming, I thought I could guess like 75% correctly or something, and we did the whole thing, and it turned out that the average performance of these 20 people was 39%. If you were to put an ape in the room that had no clue what the A/B test was about, they would have scored higher than we would. And in some ways, it demonstrates, the danger of being too intuition-based, decision-making, rather than having data-driven decisions.
Yeah, but then you kind of assume that these A/B tests were correctly performed, that they were statistically independent, had the correct sample sizes,
and these kind of tests, A/B tests, were actually, selectively chosen to be a bit extreme.
Yeah.
So sure, but still, it demonstrates, the danger potentially of having too much intuition-based decision making being made.
Yeah, but then if you're talking about healthcare, it's not about being a machine. You have to take other considerations in the patient. Right. Mm-hmm. It's not the black and white, factory. There are a lot of personal choices, and you're sick, and so it's not that easy to make super data driven. I mean, when it comes to productive planning.
So let me say, another thing that we said, we can differentiate between being data driven, being data first, or data only, versus being data first. Sorry, you take those two, or data none, I guess. Data none is basically intuition based. Data first is saying that you use data, but you always have human in the loop. And being data only is like you don't even care about the human, understanding. And I guess in your case, having data only would be super dangerous especially in a medical setting, right?
Yeah. I don't think. I mean, there are not any. It's not even close, I would say.
Yeah. But at least having the data driven or data first kind of approach, where at least you use data as some kind of input to the humans to make a decision.
Yeah, when there are if you talk about this, when we apply AI today at the hospital, so one thing, we have a project now where you look at lesions in the brain for MS, and you want to see how they grow over time, and then you want to compute their size in a volume, basically, on a 3D rendering, and a image segmentation algorithm can do that much more efficiently than a human.
Right.
So it's more about doing very accurate, and using AI and tools, especially on imaging, for segmentation, understanding, finding things that the human eye can't see. But there will always be a human in the loop verifying that, you're right, I see it now. Yeah.
But can we categorize sort of the main structural use case categories of AI in a hospital setting? Let me try. So I think you have one category, which is AI applied in relation to a therapeutic approach, like what you explained now. So here we have a medical condition, and we are trying to use AI to improve the process around that. Then we have data and AI, which is related in different categories around hospital administration or hospital operations. So what I'm saying is we have a lot of different use cases, but we can put them in the cluster of therapy, how we become better at treating patients.
Well, it's both diagnostics.
Yeah, diagnostics.
Finding out, and then there's also making a decision based on data.
Yeah, but for what I'm trying to say is this is in relation to diagnostics and making the patient well. This is one big area of how we use AI in different ways. And cancer, spotting cancer, all this, is a simple example. But here we go into another area, which is, to me, hospital administration or operations.
Yeah.
And here we can have several clusters. I would argue that you can, with data, have one cluster which is really about automating wasteful, really stupid work. So AI and algorithms, whatever, let's not use the word RPA, but you know what I mean. I'm talking low life, stupid automation, AI for automation in hospital operations.
Yeah.
And then I would argue that you have a huge field of AI for optimization in many different ways, from logistics to planning to, flow of patients to the core KPI, of patient. So I don't know. I mean, like for me, it's all over the place when I hear these different, we hear cases, but diligently driving automation, hospital operations optimization, and then patient. For me, it's a very simple.
Obviously, one other big area is NLP. And, a lot of stuff now is dictating voice and then somebody transcribing that.
That could be
text.
That would be its own category.
And
even.
Also in a lot of situations, you're tied up with your hands, and having a voice interface is also very interesting. And there's a lot of activity there in hospitals. Understanding, these type of.
Yeah. I mean, I think it's a good learning that in general, people keep confusing AI as something that is going to replace humans. It's not really about that at all. It's about adding another tool that allows you to work with data in a more efficient way and just have another way to represent the data.
I really want to talk about, more in a little bit more specific. If you're talking about recommender systems, segmentation, clustering, regression, and predictions, it's more interesting to see how you can apply those type of machine learning techniques instead of just talking AI in general.
But isn't this the problem, that as long as the politicians and whatever who's in charge or hospital administration, they are not, we are living in this high level executive 10,000 feet. You can't work with AI in this level. You need to go down to the concrete mathematical problem.
Exactly, and it starts with the data.
Yeah.
So that's been our, we really have to take control over the data and, understand it. Because one major difference with healthcare is like hospitals like Karolinska is going to be here in 100 years, 200 years, 300 years. People are going to get sick. It's not like we're going to go bankrupt. So it's really, we are collecting data for the prosperity, for everybody in Sweden. And we also have to do that correctly. It's a big responsibility to do that in a good way.
I need to bite my tongue now. I need to bite my tongue.
We don't have that much time left, but something quick perhaps.
We talk in the latest AI strategy document coming out of the government. I don't know who I read it. AI Sweden posted something. It's from the government in October, quite recently. We talk a lot about open data, right? We need to have open data. And of course, that is a great idea and great to say that. But to me, open data is all about the data management and the technicalities of how we're going to build these systems. Or, I don't know. I mean, like we're talking about this as something simple. Obviously, yes. But the problem we need to talk about is data management.
Yeah, I mean, we are talking about, what we are looking into now is to, have more unified interfaces and structure around data so you can query it and understand what we have, an API-driven approach.
Exactly.
So for me, open data is more about, our role in society, what type of data we could share. So in a pandemic, I would argue that would be beneficial to release data from quality registers or whatever for people to use. And it's more about democracy and being transparent, as a government agency. So we're not kind of hiding anything or doing.
No, we can use stuff. But what I'm trying to say is exactly this. this is great, but it will not give any value if you don't have the fundamental architectural approaches.
There's no point of releasing open data
when you can't use it.
You don't understand it.
Touche.
So that's the...
I think it's more important to work with closed data than open data, actually.
I agree, but 100%.
Okay.
Sorry.
Awesome. And I'm I would like to move also into the challenges that you have in Karolinska Hospital when working with data and AI and, when it comes to procurement or these kind of regulations, etc.
Yeah. So one of the problems we're seeing, there's a big trend now with cloud moving to the cloud, and especially startups in the AI world, they all go to the cloud first, because there's no point of them doing data centers, buying GPUs and it's a real problem for us because of Schrems and this whole business with regulation and EU fighting the US and NSA backdoors. Yeah. We can't really put, a lot of these systems require you to take the data from the hospital through a gateway, upload it to the cloud, do scoring, training, whatever.
Do you actually do that on Karolinska? Do you use any cloud services today?
Yes.
You are? Ah, nice.
But we do careful analysis, and it's definitely not broadly used. So there are a few.
But you do have a number of on-premise machines as well.
Yeah, so that's our strategy now, because we see there's a limit to what type of applications we can do with these type of vendors. So when you want to do more interesting things, combining data, our only option today is to do it on-prem. So we've been investing the last year heavily on kind of a modern cloud, private cloud infrastructure.
Cloud,
yeah. So it's based on Kubernetes and...
Which one, if I may ask? Do you have any specific on-prem Kubernetes provider?
So we work with Red Hat OpenShift.
Nice.
And we're really trying to build an environment where you can work cloud natively and with modern technology on-prem. So it's a hospital. We have a lot of hardware resource. We have, power, compute rooms. It's a big, Karolinska's budget is around 2.5 billion euros. So
euros as well.
So
per year.
Yeah. So it's like a big. We can afford to invest. And if you look at things like we store petabytes and petabytes of data, and if you go to public cloud services, it's not really the case that it becomes cheaper for us. If we have the power and we have the computer rooms, when we come to that volumes, it becomes cheaper for us to do it ourselves. What becomes maybe is these big tape robots, and when you come to like cold storage, and that's where the cloud vendors really can press. We have to make very large investments to. With those type of things.
But how are you tackling this? Because it is technology, there's data, there's processing, there's governance, this is operations, this is competence, talent, the team. Are we going to go monolith? Are we going to go distributed, modular?
No, so we're kind of hedging now on. We have to do more development ourselves and be more be more. Modern to meet the requirements, especially for our highly specialized mission.
So even you need to become a little bit more a software company yourself.
Exactly. So we are recruiting developers now.
Fantastic.
So we have regular full stack, developers. We have about 10 now, and a lot of people coming in.
Is that being organized in a central group?
Yes. Yeah. And so we are, doing also agile, DevOps, these type of methods. So we're doing.
But this is a huge shift, because you started with saying that, one of the biggest differences when you go to Karolinska, you're stitching someone else's systems together.
Yeah.
It's more about buying systems. And what you're saying is that route will not take us the whole way when it comes to data.
No.
Why not? I fully agree with you, but why not?
Well, if you talk in the broader picture, these monoliths, they are ecosystems in themselves. And basically you are putting your bets on that this vendor can meet all your demands within their ecosystem or budget. But if you want somebody who has any kind of leverage in the market, you go to these huge American companies. And they have hundreds of customers, and why would they support your particular use case? And we have problems with Swedish regulations, different. So our approach now is to provide more of a platform approach or a data approach, where we want to structure data and then, modularly build applications on top of this API platform.
This is fantastic,
to deliver.
in my opinion.
So we are building that platform now. Extremely interesting work, and it's this unheard of.
This is unheard of in this space, right?
Yeah, so it's a big bet from us, and we are really focusing, and so we're really trying to find the right people to help us. I think if we can pull this off, it will be a game changer.
I think a lot of organizations in the public sector in Sweden is actually trying to do the same, but very few have the resources to try to do it properly. And Karolinska, I think, is one of the few that actually do
because
have
our BI team has been there for, we've been doing development and supporting decision making for 10, 15 years. So we have a tradition of developing around data. What we're doing now is to kind of expand that into applications as well.
But to me, the storytelling you're doing now is something I never heard in the public sector, because people are trying to stitch things together without caring about data management, integration, or data products.
Yeah, and we are a little bit fortunate because there's a standard that's been around for quite some time that's finally gotten mature enough so it becomes usable. So there's like an international standard for storing clinical data.
What's the name of that?
It's called OpenEHR.
Which is a quite important piece of the puzzle.
Yes, very important. And there's also in the US now, there's another interoperability framework called HL7 FHIR, FHIR, which is being mandated by the US government for hospitals there to interchange data. So standardization is being pushed, right now, just the last 2-3 years.
You open up so many Pandora's boxes that I want to dig into after work, maybe. Standardization and what level to do it on protocol, really detailed versus
OpenHR is really, the approach there is really interesting. So you have a common reference data model, which is dedicated for storing clinical information, and then it's coupled with a informatics framework and a query language.
All right.
So it's an entire system, and the idea is that it's segmented in two parts. So you can do the modeling of the data. Typically if you have a form where you enter clinical information when you're treating a patient, you as a clinician can sit in a low-code tool and build that form, and then it gets serialized or stored in a very interoperable format in the standard reference model. So I can just take that thing, put it in some other hospital's OpenEHR system. It
sounds too good to be true, but I hope it's correct. But yeah, to have that kind of standard, of course, sounds like an awesome thing. Okay, so time-wise, we're really getting to the end here a bit, and we have so many more topics that we would like to cover. And should we take at least and try to have this a bit short, but it's a big topic, so it's really hard to do. But okay, so speaking a bit more about the legal challenges when it comes to data, and specifically about EU versus US and being able to move data back and forth. There are a number of challenges there, right?
GDPR is just one thing for us.
Safe harbor. Yes.
So, and we've been following this whole development for a long time with Schrems 2 and those,
I think we need to unpack that a bit. What does that mean?
So, if I get this correct now, I'm not a lawyer to start off with, but the GDPR and the basis to transfer data to a third-party country, you have we had three options. You had what's called Cloud Act or Privacy Shield. It was a legal framework for doing that. And you had...
That was in 2016 or something, right?
Yeah, Cloud Act, but Privacy Shield was really the Schrems case, so we're going to get there. But then we have standard contractual clauses, SCCs, which is basically the only thing left. And then you have some other type of... I forgot the name of the third option. but it's not that commonly used. So most cloud services and most vendors now rely on standard contractual clauses, which is the legal framework. And there's an activist, Max Schrems, in Austria, who sued Facebook for violating GDPR, especially around the Privacy Shield agreement.
This was in 2015, 14?
I think there's Schrems 1 and Schrems 2. So Schrems 2 is the recent one, and there was a ruling in Ireland where Facebook legally in Europe is located, and we basically violated Privacy Shield. So you can't use that framework for transferring data anymore. And the repercussions of this, we haven't.
Wasn't it the first one? Wasn't it something like when Schrems, first sued basically Facebook, I guess, and then he won in court, in the EU court in some way, and they had a safe harbor law coming up after that, right?
I don't remember the early ones, but the interesting piece now is that so after Privacy Shield fell, and that was really an important ruling, because the EU really put down the foot and said, we can't allow NSA to have backdoors into and getting our data.
Period.
So it's called the Foreign Intelligence Surveillance Act, or FISA, which is really the problem. And what now the EU says, like for SECs, they say that if you're using SECs, you as a company have to make sure that the country receiving the data has an equivalent, view on data privacy as the EU. And, if you look at this and with the US, so I'm expecting SECs to be, unless there's some new framework being developed and, there's a way of controlling this access to data through this FISA.
Yeah. But if we try to, there's a lot of technical terms here and a lot of legal terms here as well. But in short, it will limit the way that we can use cloud services in different ways, right?
No, so I think the problem is that there could be a court order in the US where they have suspected terrorists, and they can tell a cloud service that can you please give us data on this individual? And they can release that data without telling their customers.
Yes.
And Microsoft, in their transparency report, they say that we do this 100 times a year, something. So they can't say it doesn't happen. And we really don't know exactly. But
isn't the purpose or the problem from Karolinska's point of view is that it actually does limit the use of cloud services because they have this kind of
exactly. So the legal people say, we can't allow this to happen, even though the risk of it actually affecting one of our patients.
But compliant wise, what our law says, what the integrity level we need to uphold, what we have promised, the promise and the service is not compatible in such a way.
So it's really more the EU GDPR versus the US and their surveillance laws. And, there's no technical measures really that you can use. There are cases where you can encrypt the data, store the keys keep the keys, but then you can't process it. You can only archive it or store it. And so those are kind of okay. Or if you have completely anonymized data, which is not, you can't detect if it's
I think Google Cloud at least have now the key management service to allow you to store the keys yourself, etc.
They all have it, but the problem is
they don't all have it. But okay,
they don't.
No. But then that's just the first problem. The other problem is we have also offentlighets- and sekretesslagstiftningen in Sweden, which is even more problematic because then. So GDPR is you get fines if you break GDPR. Nothing else. It's a risk, and the media coverage. So it's a big risk. But with sekretessreglerad information or secrecy, and that's a felony. You can get convicted. Anders, you probably know about this. You keep a lot of secret information, and so there's actually a proposal now to add a new sekretessbrytande förbindelse, so you can allow other agencies or companies to technically process or store data.
even if they don't see it or whatever.
And also it's kind of they're trying to limit. So that's the other law. And then in the healthcare sector we have patientdatalagen, biobankslagen, and a lot of other complicated.
And bottom line, paralyzation, right?
And the bottom line basically is that it's hard to make the legal frameworks keep up with the technical possibilities, and to make use of all the possibilities that technological advances are providing for us, right?
One important thing that study with this new framework for releasing data is that they actually put their foot down and said like outsourcing is a necessity. If you want to be a modern country, all government agencies can't have their own data center. So they say that, legally we can say it's a necessity. You have to be able to outsource some information. And then we don't have the legal framework for doing that when it comes to these type of sensitive data in Sweden.
I think a problem as well is that the biggest and the best cloud providers that we have in the world is the American ones and the Chinese ones as well. And we don't really have a European or certainly not a Swedish one.
No, but if you look at what happened in France just a couple of weeks ago. So Thales, this big security firm, they have a partnership now with Google Cloud where they create a wholly owned European company to avoid this whole legal, US.
So something here will happen. The European cloud in some format. It seems like a necessity.
Yeah, when you have this, what's it called, Gaia X as well.
Yes,
it's
Germany based in France and etc. But EU finest cloud.
But you have to remember, like the Amazons and Microsofts and Googles of the world. They started out very, very successful businesses, ad sales, Amazon. They just poured money into, I don't know, they invest hundreds of millions of dollars.
How to catch up? Impossible.
I don't think people realize that all these kind of cloud services that we have today from Amazon, Microsoft and Google, etc., is that they basically open source the internal tooling that they have been using for 10 years before that. And it's so much work being, poured into that before they actually.
BigQuery was not built for Google Cloud; it was built for processing data inside Google to be able to sell ads to people.
I still wish the best for Gaia X and other kind of European initiatives, and there is a Swedish one as well, trying to have some kind of Swedish public sector cloud provider.
What we're trying to do, and we're really urging the vendors we talk to, is at least do Kubernetes type of deployments so we can work in a modern way, because then you can technically also operate them on a public cloud. So Kubernetes becomes the
containerized approaches means that we can be more flexible.
There are these interesting concepts now around operators, which is a nice way of maintaining software on Kubernetes, which is really interesting. And we're seeing some platforms like Snowflake is maybe not completely open, but at least you can choose your cloud provider. Databricks is the same type of strategy now.
But not on-prem though.
No, exactly. So obviously because we can't on-prem provide the scale and all the services, but so we are really looking into the modern solutions which you can deploy using Kubernetes. Things like Kafka is already there, and there are a lot of other technology.
I think we need to collaborate more in Sweden, in the public sector especially, to make sure that we have the proper like on-prem or at least some kind of American cloud solutions.
Yes, so one of the ideas we're trying to pitch is, get onto AI and algorithmic development early and to have a partnership with so a lot of the clinicians have ideas on what they want to do. But instead of them going to a public cloud and being locked into that, because that would be the same business decision to do, we have to provide an environment where they can work, collaborate, on an on-premise setting, which we then can deploy on other hospitals in Europe and in Sweden.
This is, I think this is a very exciting proposition, Henrik. And I think for me, this is refreshing because I haven't heard, I wasn't aware that you were going in this direction. And I think it's very, very, very interesting. It's a super hard problem we are trying to solve, right? But you are trying to look at it API based.
So we're really getting the people, the development into the data instead of releasing the data.
That's the point.
But I think a lot of agencies in Sweden actually are trying to do this. It's just that some are a bit more ahead than others. But everyone is trying to do it.
But then I would argue
they can't really do it themselves. And I think
how do we coordinate this? Because now, I mean, like knowledge sharing, double loop learning. How do we actually then get the fundamental problem following data in different ways?
Yeah, exactly.
Is some way not actually architecturally a generic problem, or well, if you crack the code in Karolinska, why can't you use that in another setting?
I think that there's so much details in the type of data, it can't be generally applicable to any type of data.
No. But technically, can't you build templates, scaffoldings, infrastructure as code out of what your guys are doing to reuse fundamentals to get faster starting? Okay, they need to have their own use case.
If you look at machine learning and AI, there are of these types of frameworks, or there's this. Peltario might be one. I don't know if they deploy on premise, but we have the HopsWorks and the lot, where they try to do these more. I think there's open data platform, something Red Hat does. We really try to put together an entire platform where you can do inference, model training, feature management and all of that stuff.
I mean, it's a big problem, and the whole field of cloud computing in general is moving so fast, and the whole big tech giants are moving, of course, in a pace that is really hard to keep up with. And but luckily, there are a lot of open source initiatives that makes it possible to at least move rather fast. But it's super hard to keep up, right? Would you agree with that?
Yes, I mean. Biggest problem for us now is to get the right technical people, developer skills.
So
come to us.
Are you trying to recruit?
Yes. So
100%, or is that even feasible?
No, but we have to. Bring on. Now we're looking at more, developer ops people, developer
data ops.
Yeah, just to be able to manage the data. But so we're not actively searching for data scientists to do.
No. This is data management data. This is data processing.
So we have to lay the foundation of this platform, and that's what we're trying to build now. We're also having a more application development where we do systems to support,
back and front end engineers as well.
Yeah.
Awesome. Yeah, we're already over time, but let's try to take some time for more philosophical topics as well, if we could. And one obvious question, we always bring it up, but we have spoken about it so much already, which is the AI divide. And the general premise of this is basically that we have a few set of tech giants, the Google, the Facebook, the Microsoft, the Amazons, and the Chinese, Tencent, Alibaba, Baidu, etc. They are moving so fast, especially when it comes to cloud computing. And I don't think people realize how much work it is to have a proper working cloud service in there. And the level of functionality that they have there. So to actually catch up with that is super hard. Do you think that kind of, if you call it AI divide or cloud computing divide that we have today, will it continue to increase, or do you think it actually will be?
It will increase as long as these companies can harvest data freely. And that's really what driving their innovation is. That Facebook and Google, they can just bring in everything.
They just click a terms of service agreement, and then
that's what driving the development there. As long as it's unregulated and they can make hundreds of billions of dollars on it, they will just buy a bigger computer. And that's the way it's going to work.
Do the brain drain and buy other companies and continue to expand.
Yeah, that's just the mechanics of capitalism in this case. So I don't think there's not much we can do, and just hope that they can release, papers or being open of what they're doing, and so we can apply some of that.
And what's the strategy for the rest of the world to catch up, or to sort of? Because part of the AI divide, I think, is the concern of when some few has the power in terms of knowledge or money or know-how, according to the rest. When the concentration of power is so, this is scary.
Yeah, we have to stop falling for the baits. We have to stop just, Gmail is so convenient. You can buy another email service that doesn't harvest all this data, and track you everywhere, and it's not worth it. So people have to become aware of, what even the search engine. There are actually alternatives. I don't use Google anymore at all.
DuckDuck.
Yeah. So
which one do you use?
DuckDuckGo or
DuckDuckGo?
Yeah. And so it works fine. I mean,
let's do some marketing. DuckDuckGo.
So there are alternatives, and I think that's the real problem. Why these companies have grown so large is that they, Spotify, is in similar territory. I mean, the real interesting piece about Spotify is that artists can understand their audience because, suddenly you understand what people are actually listening to at every second, which is like a dream come true for commercial radio,
But isn't Spotify in that case an exception to the rule about the AI divide, that even though Apple, Google, Amazon, all of them tried to make a music service that actually did work and could, take down Spotify, they all failed?
Yeah, but that's because it's not an AI problem. It's about
It partly, right?
Yeah, but I think even the recommendation system Spotify has a slight advantage, but I don't think they're that great.
Why do you think Spotify succeeded then? Why didn't it?
They were first.
It's that first mover advantage.
Exactly, first mover and growing, and also being aggressive. As I see it, the growth has become mainly in expanding globally. Getting all the contracts and all the licenses, expanding globally. And of course, it's a great product. And there's also the brand hype and, being independent and,
cool.
A little bit cool. So I think, but I wouldn't say, from my experience, all the A/B tests we did, it's not, that didn't move the needle of Spotify's growth. It was just market expansions, business things that.
But okay, but we can potentially still phrase it. There are some light in the tunnel that the AI divide will not continue to dominate, and all the services will be moved into more and more tech giants. There are chances, there are possibilities for startups like Spotify to still compete, right? Or
I mean, it's hard. Especially when it comes to deep learning or these type of brute force like GPT-3 and, who wants to spend 200 million on training those models? And
we're doing that in Sweden as well, So.
Yeah. So I don't know. I'm more interested in solving the right problem that's beneficial.
I like that.
Self-driving cars, yes, could be interesting, but a lot of stuff, optimizing.
So sustainability or health is interesting problems to be solved.
Yeah, and I don't think we need humongous amounts of compute to solve a lot of interesting problems.
But what is stopping us to solve? Why haven't we become better throwing data, building journal system for years? What is the fundamental problem?
But as I said, Anders, there's this famous paper from Google in 2015. Yeah. It's all data scientists and everybody's focused on like the small piece in the middle, which is about the algorithm and hyperparameter tuning, whatever. But it's the whole piece around it, and that's where Google and those guys excel. Managing the data and orchestrating. Quality. And
no, but I think you're misunderstanding here, because that's really why tech giants are winning.
Yeah,
that's really why tech companies are open sourcing models and code, because they know it's the 95% around the model that is really the hidden secrets of how to succeed.
And of course, huge amounts of data.
No, but let me flip it. You don't understand, Anders, because this is easy to understand in Spotify, which is a tech company. I understand that. And then I go to Karolinska or to Scania or to Vattenfall, and they are completely disorganized in terms of understanding the holistic problem. So I would argue that Karolinska's biggest problem, Scania's biggest problem when it comes to really get ahead, is an orchestration problem in understanding how to holistically, if I understand the reality of what you said, it's not the parameter tuning, it's the whole thing. And then I say, okay, how do I solve the whole thing in Karolinska? Good luck with that.
Yeah,
holistically getting everybody to pull in the same direction and understanding their piece of the puzzle.
Yeah, and
that's what I think is the real problem.
Yeah, and also trying to, the people within Spotify, I learned a lot of these things. Yeah. What it takes to become, as Lalle used to say, Lars Albersson, to get to this industrial stage, where these giants are mass producing these things, just dealing with hundreds, thousands of data sets. At a hospital, we're never going to get there because all our data is hand generated, It's very totally different. So for us, it's more about accuracy, quality, and being very, very close to doing the right thing. We can't just do whatever works, like a recommendation system.
So it means also that when we understand the full picture, like we said, not only the whole thing, you need to put that in the context of what is hospital business and how does that work? How would I industrialize this, so which is completely different.
Data is not data. I mean, Google's business is very, very different from a hospital business.
Of course. But the problem we have right now, in my opinion, is that the way we are organized and the way we understand and have the data literacy around these things, we have the wrong mandates, we have the wrong orchestration, we have the wrong different separation of IT supply and demand, vendors, we have no tech know-how, how to build stuff our own. So the starting point to even get started is so far behind. It's not a tech problem at all.
No,
in my opinion.
I would agree. So for us, is what we didn't even have infrastructure to do anything. So we started with infrastructure. We had, our BI team. We did, analytics. We started doing predictions and, looking at, have flows. And so it's pretty mature, but to take the next step, we have to bring in more data, combine more data, take a simple thing like in emergency. If it's snowing outside, we know more people are going to come in. We see the weather forecast. We can, start preparing for that. So there are a lot of these things that you can become more data driven.
But to actually do become data driven, I think we need to have the infrastructure in place as well, which is something that is strongly lacking, I would argue, in Sweden and in Europe, and what the tech giants have.
Yeah, but so we have, like, we take another example on that. So we are one of the few hospitals in the world that do whole genome sequencing for treatment of rare diseases.
Cool.
And so that's a big investment area for us now, trying to bring that onto other types of diseases like cancer, where, genetic markers could be interesting to, called precision medicine, to individualize treatments. And other things. So
not only personalized music, but also personalized medicine.
Exactly. And it's about, and that will require a lot of, computational infrastructure, storing data and know-how. So we have actually a functioning pipeline together with SciLife Lab that we use. And so we are looking now onto, kind of factorizing that and scaling it out and to bring on more interesting use cases.
Cool. Let's try to end on some kind of positive note, because I think we've been in a bit negative kind of discussion here.
Frustration came out
about the lack of how can we ever catch up, and we do know that the tech giants have so much more than the knowledge about the AI. It's also about the engineering expertise, about having the right infrastructure in place to be able to make use of it and implement it, and that is something that we're lacking.
Exactly, but I just want to say that I read this quote that the 2010s will be remembered as where the talent of the world went into selling ads to people. It's not a mission.
Oof, I love that. That is another T-shirt.
Yeah, but it's really like I can't really say why you would be interested working for Facebook or Google.
Maybe that
ads.
Is the positive, that people will run out of energy to selling sodas, like the Apple quote, right? Or selling ads. That people which are smart people wants more.
Exactly. I mean,
and that is
people
maybe
come
the saving.
to Google and Facebook for the technique. It's not for the business. I don't think people are very engaged in selling ads,
No.
So people want to do because it's a cool place to be and they have cool products. But I think at some point that has to shift. You have to think about why,
So the strategy is to make Karolinska cool.
When people get older, maybe, they get tired of being in that business setting and they want to do something more important.
Can we repeat what you just said? Move from selling ads to what? To...
I mean,
you said it so.
Have a better societal impact. Do something for everybody. For
but
the
people
world.
will grow tired of selling ads or something.
And I mean, now with Google, Facebook. We're doing so much good for the world. We have all these services. I can use Instagram and post pictures of my kids.
Ads.
Yeah. So I think as soon as people start, and even also people within those companies, is it worth it? And take that knowledge and move it down to where you can have a much bigger impact.
So maybe if Karolinska and the equivalents can be a little bit better at being attractive and sort of, like now there's too far ahead to be even considered. But if you get a little bit better, so they have, this is pretty cool stuff they're doing in Karolinska for a good cause. And they're, Henrik Löf's storytelling, that was cool stuff. I want to work there. It doesn't mean that you need to go the whole way, but they need to get out of the dark ages.
Exactly. So,
and if you can get out of the dark ages, maybe you can flip it, that the talent will come.
Yeah. So we're really trying to have a strategy now where we need some kind of lab. It's called bimodal IT.
I understand.
You have a development, and you have to do prototyping and understanding, and then you have the solid foundation. Every product company has a bimodal, and so we only had one mode. Mm-hmm. So what we're doing now is to bring up the first mode, and also building a better architectural platform and vision of delivering, apps and a modernization of digitalization of
but this is the point. How many data engineers knew that we had some cool stuff going on here? I think this is a good story.
Yeah, and we really need help, and we're looking actively for people to help us. I need somebody who can, write Spark.
Yes, exactly.
Okay.
To come to us and help us.
And it's hard to recruit also in the public sector as well.
Because we're like competing with the Spotifys,
yes,
and
exactly.
We can't provide you with stock options, cool parties, and I'm done with that, so I'm fine. I love my work, so it's but not everybody have. People have other.
Well, I think what you said. 2010 and perhaps 2020 will be the time where people stop caring about ads and start caring about people. Right?
I like that.
I hope so.
I think that could be an awesome thing. Henrik, what's next in your life? What's happening professionally, personally?
Well, I've just started this journey now, and I want to see it through. So I'm not saying it's not smooth sailing by far. It's a lot of hard work, but I'm really excited about this direction we're heading. And we might fail, but that's okay. Then at least we tried. But we can't just not do this because you will only fail. So that's the thing we're doing now. Let's really try to do this for real. And the whole precision medicine, is also very interesting. Yeah. And, so I'm just...
If anyone is listening to this and they really care about, healthcare, how can they, join or find more information about potential roles that you're hiring for? Or
so we have
in touch with that?
I'm on LinkedIn, but we have also 8 roles out now. 8 roles?
Can you name some roles that you have?
So we have data engineers, looking for data engineers, BI development, a UX designer, and I remember everything there. But I guess I can post a link somewhere maybe to recruitment. So we're really trying to build the one-legged, more development culture, and we have started working on the infrastructure and being a modern development organization.
Do you have a specific sort of target goal vision for 2022? Or is it something that you sort of in your budget and plan for next year? What we
want to do is, so key for us is to liberate data. So that's common in these organizations, that data is siloed into these different systems. So now we're capturing and integrating this data and collecting it into these standardized APIs and building an application. That's really the goal for a couple of applications that really can support the improving, automating the process of some internal flows in the hospital.
And sounds awesome. And I think other public sector or companies in Sweden that are interested, we should try to find a forum where we can share experiences and actually start collaborating, because I think we are too small, for one, as a country, but secondly, as organizations here, to do everything ourselves. And we may not be able to share data, but we can share a lot of other things. And one of the things is just experiences, best practices, and perhaps even models at some point. At least, if we start learning from each other about both mistakes and successes that we have, I think we can actually move surprisingly fast. And Sweden, I think, is one of the best positioned countries in Europe, at least, to actually make this happen. Since the great universities like Karolinska and other normal universities we have in Sweden, we actually do produce.
And we also have a lot of venture capital lying around.
That's true.
We need to put into use, to do the right thing instead of just
equally sexy as any other startup. I'm telling you.
Yeah. Henrik, anyone that you would recommend to join this podcast? That's someone that you like to listen to potentially here on this podcast.
Well, if you really want to have somebody talk about, who knows how it is to run a hospital, it's Kalle Conneryd Lundgren, who used to be the operating manager of the hospital. He's now at Klarna.
Oh, okay.
So that would be maybe an interesting talk with him to see how he is, he's a surgeon, from the beginning. And he was, extremely interesting in data drivenness and doing data analysis. And now he moved to Klarna.
From Karolinska?
Yes.
So this is this is the other way.
The other way around.
It is a bit strange.
This is just amazingly fun.
And he knows on his fingers how healthcare works.
Right.
And the problems with healthcare and, the data in healthcare.
Exactly. Sounds great.
That's an awesome idea.
That sounds perfect. Okay, cool. Thank you very much, Henrik. It's been a true pleasure. And we already went 20 minutes over time, but we could have spoken for hours, I think, more.
There were so many rabbit holes to go down.
Stuck in this whole computer architecture.
No, but it was fantastic. Fantastic.
I think a lot of people learned a lot about, the computer architecture and the differences between different HPC kind of architectures and whatnot. Awesome. Thank you again, Henrik. Let's continue with the after work.
Yep.
And best of luck with 2022 and Karolinska.
Thank you.
Thank you very much.